You've probably seen AI art at least once. In the past year, AI art has sparked controversy all across social media. This ranges from copyright laws, to dumbing down creativity to just writing a prompt, and even whether or not AI should be considered art. But above all else, one thing remains clear. Trying to differentiate AI and human art is nearly impossible. I mean, take a look at these two paintings of a bowl of fruit. Which one is AI? Well, it's actually a trick question because both of them are AI generated. But hopefully you get the point. It's difficult to differentiate between AI art and human art by just guessing. And unfortunately, this becomes a problem when AI art poses as human art. The most infamous example of this is in 2022, where an artist named Jason Allen submitted an AI-generated image created with Midjourney to the Colorado State Fair. The project won first place in the digital arts category without initially revealing that AI made the image. And as many people have complained, this misrepresentation prevents appreciation for genuine human-made work, undermining trust in artists and their authenticity. But what if we use AI to detect AI-generated art, like GPT-0 but for art? Could it work? Or would the AI become just as confused as us humans? We decided to test it out by building our very own AI art detector model.
Before we delve into how we made our CNN AI model, let's define what a CNN is. A CNN, or convolutional neural network in nerd terms, is a deep learning image recognition model designed to automatically learn and extract spatial hierarchies of features in image data to be used for classification. In normal words, it's just a model that learns about a set of images by making predictions about its class and correcting itself to become more accurate. Think of it like an unemployed teenager trying to become an expert at recognizing fast food french fries. At first, he struggles to differentiate between restaurants, but over time, he begins to notice the distinct tastes, seasonings, and shapes of the fries, and soon enough, he's a master. In our model, we taught it how to differentiate between real human art and AI-generated art. And for this, we used a convolutional neural network. Here's how it works. First, the convolutional layers scan the image and detect important patterns like edges, colors, and textures, giving the model its first understanding of what it's looking at. Next, the pooling layers reduce the size of the data, keeping only the most useful parts and helping the model focus on what really matters. Next, the flattening layer converts all of that visual information into a long list of numbers that the model can easily understand. And finally, the dense layers use that information to make a decision. Is this image made by a human or an AI? Since this was a binary classification task, the model had to choose between two options, 0 for AI generated and 1 for human made. Over time, with enough training examples and feedback, the CNN learned how to make more accurate predictions over human versus AI generated art. Let's look at the dataset that we used to train our model. We used the AI Art Bench dataset from Kaggle, which is a dataset derived from the paper Art Brain, an explainable end-to-end toolkit for classification and attribution of AI-generated art and style. In our code, we used 3,410 images, and 80% of these images were used in the training set, and 20% were used in the testing set for the model.
But we didn't just stop with one model. We built a CNN from scratch first to understand how the architecture works and how well a custom model would perform. And by scratch, we mean that this model was made from scratch and that we designed the architecture completely. Then, to push performance further, we experimented with the MobileNet V2 and ResNet 50, two powerful pre-trained models that already have experience classifying millions of images. We fine-tuned these models on our dataset to see if their advanced feature extraction could give us better results. Essentially, the convolutional layers are already preset on these models, often being more intricate and complex, as well as more accurate than scratch models. Testing these different approaches helped us see what worked best for our specific task, separating human creativity from AI mimicry, and gave us a deeper understanding of how different CNN architectures impacted performance.
Let's move on to results. Our results were pretty great. To analyze how accurate our models were first, we used a classification report with metrics like accuracy, recall, and precision. Here are the equations for all three. Basically, accuracy is a percentage of total predictions that the model got correct. Precision is like out of all the times the model said positive, how many were actually positive. Recall says out of all the actual positives, how many did the model correctly identify. Putting these metrics together can give a pretty good idea of how well a model performs. In our project, we tested 3 models, a ResNet 50 pre-trained model, a Scratch model, meaning we designed it ourselves, and a MobileNet V2 pre-trained model. Here are their metrics side by side. As you can see, overall, it seems like the Resonant 50 performed best. So why did Resonant 50 perform best? 1. Pre-trained weights. Resonant 50 uses pre-trained ImageNet weights, meaning it already understands basic image features like edges, textures, and shapes. That gives it a big head start. 2. Depth and architecture. Resonant 50 is deeper than MobileNet V2 and more sophisticated than the Scratch model. Its residual connections help it avoid issues like vanishing gradients, making learning more effective. 3. Training from scratch is hard. The Scratch model had to learn everything from zero with limited data, so it couldn't generalize as well as these pre-trained models. Okay, enough of these numbers. How do these models work for actual art?
Here's a sample AI generated image. As you can see, the models will first process the image and then spit out a prediction for whether it's AI or not. Here are some art pieces that the Resonant 50 model did well on. Pretty interesting, right? The model is able to learn subtle differences between real and fake images and apply it to complicated questions like these pieces. And here are a couple images that the model guessed incorrectly on. This shows that deep learning models still aren't perfect for differentiating human and AI art. But their remarkable accuracy is a good sign that in the future, more complex, detailed models may emerge with even better performance. So why does an AI art detector really matter in the real world? Well, there's nothing inherently wrong with AI art as long as it's properly disclosed. In fact, many digital artists use tools like Midjourney or DALL-E to generate initial concept art or backgrounds, which they then paint over or refine using Photoshop or Procreate. Prominent artists have even shared their workflows openly, blending AI assistance with manual effort, similar to how photographers edit with Lightroom or filmmakers use CGI. When properly disclosed, these hybrids are seen as valid artistic expressions. And so, while the future for AI art both excites and worries artists around the world, this project shows the potential for safeguards against people who try to pose AI art as their own. In this video, we hope that you learned more about both AI art as well as convolutional neural networks and their use cases. If you want to learn more, we've linked a couple of tutorials below so that you can make your own CNN model, and we encourage you to explore CNNs in your own time. But until then, thanks for watching, and make sure to look out for more videos on the Epoch One YouTube channel.